Virginia, there is another arm to this study, and I coordinated the non-cognitive science arm, which is also known as the content arm. We had a parallel structure to the cognitive science arm, and we had an essential question, research question to look at. Does deepening teachers' content knowledge of the science they are teaching lead to increased student achievement? And our task was to develop, parallel to the cognitive science arm, an 18-hour intensive professional development that took place during the summer, followed up by 8 hours of professional learning communities. And you'll notice there's some repeating of slides, and this is a cognitive science strategy of spaced assessment to enhance your understanding of these. So we actually employed 6 teams because there were 3 Holt units, biology, geology, and chemistry, and 3 FOSS units, biology, geology, meteorology, and hydrology. We employed university science professors. We see 2 biology professors here, one working in our Philadelphia training and one in Arizona. As Donna said, we have our 2 excellent science museum content experts with us here today. We also had some outstanding high school teachers. And this was a middle school course, and of course our own 21B STEM science staff. So, what did we do? We convened a team. Again, there were 6 teams. There were some people that served on mobile teams, i.e. me and some of the other folks. We took a look at the resource, be it the Holt or the FOSS kit. We identified the core concepts, and then we began to develop strategies for our summer PD. And they included direct instruction, active learning strategies, and technology. I think Joe mentioned that this was a course designed not as a science education course, but as an undergraduate science level course, sometimes at the introductory level, sometimes at a higher level. And then after the summer PD, we followed up with 4 meetings for each unit when the teachers were teaching that content unit, and that was 2 hours each. Like the cognitive science arm, we had developed binders. We put this material in our binder. It consisted of activities, PowerPoints, material, references, etc. On this slide, we see some examples of that. We have some material from geology, from chemistry, and from biology. For middle school science teachers, it was fairly sophisticated. And this is the actual training. We were in 4 cities, Philadelphia and Pittsburgh, Tucson, and Phoenix, of course, and this is some biology and geology training. A couple of things you may notice from these pictures are, we emphasize active learning, and also the teachers were very engaged in the process. One other thing, as Joe mentioned, at the conclusion of the unit, the students were given an assessment, and at the conclusion of the PLC meetings, the teachers were given an assessment. And the content teams helped inform the selection of the assessment items by taking the survey of enacted curriculum, and they informed Andy's assessment group, and I assume he'll be talking about that later. So, as Joe said, there were some limitations to the study. We treated our participants not as teachers, but as adult learners. And in that role, we did talk about the content, but we did not really get into pedagogy or strategies for presenting the material. Conversely, the cognitive science arm had specific strategies they were developing and that the teachers would use to enhance their teaching. So we were limited that we could not really use any strategies for teaching. The positive aspect of that was that the teachers were allowed to then go back to their classroom, integrate this material, and teach in the way they were most comfortable. But some of them really wanted to have more, and I think if we did a study solely on the impact of increasing teacher knowledge, it may be beneficial to, in fact, talk about how to present this material to teachers and take a look at student work. Thank you.